by providing children with things that you can engage on a computer in a way that looks much more like engaging them in a video game.
ToonTalk was the environment that children used to develop their models and to refine their models.
The big idea behind ToonTalk was to make programming much more concrete, so that instead of having to think in terms of variables and procedures, children could think in terms of robots and birds and boxes.
Translating it to ToonTalk is...
It's a lot easier because you're using pictures and actual objects that you would know from real life, rather than just letters, which could mean anything.
You're a character in this world. You have a little persona and you walk around and you sit down on the floor and build things.
The way ToonTalk is designed visually, it is very obvious. What you do almost physically is you attach a property to an object.
There's this idea of birds and nests.
A bird represents messages, sending communication.
And this bird always knows where its nest is, so that you could always give the bird things and she'll take it to her nest.
While the robots represent the actor, so to say. So when you want to attach an attribute or a value to something, then you use the hammer to manifest that this is the attachment.
Borrow as heavily as possible from computer games and video games to make the programming environment look and feel like a video game, but still be a full-fledged programming environment.
By providing some computational tools and some robots built with Lego.
ToonTalk could communicate with the Lego tangibles. The bird could fly conceptually to the brick inside the robot or whatever it is that children have made, and could turn on motors and lights or read sensors and report back to ToonTalk.
They were using the Lego robots, and they were discussing the degree of randomness of a certain robot. And they were making very strong connections between the behavior of the robot and their own experience.
It became clear under the project that this was very important to mix these things.
Both in Italy and in Sweden, the children actually took apart the device because they wanted to being in command. So their idea of driving something was then I'm in charge.
We always tried to begin with real objects or some representation of what happens in nature. In collisions, that was a very strong feature. We videotaped collisions of cars on air trucks.
What kids were really doing there was investigating what happens when objects collide.
And you could use it as a starting point for building their own models and gradually refining them.
So they might start by building a model that worked for one particular collision, say just the one where this object is stationary and this one hits it. But then, say if they're both moving, will that model still work? And typically it wouldn't, so they'd have to go back and reassess how they should model it. And so what they're actually doing was coming up with more general models. So they're learning something about generality of models, which is something that's very important in science.
And we came up with, if this one's going faster than this one.
If you build something out there on the table or on a screen, you're simultaneously building something in here.
We have been surprised that the students have really made observations that we thought was far beyond their abilities.
Of course, they are not mathematicians, they are not scientists, but they are maybe doing something more than role-playing. They are not playing as scientists.
Think about landing on the moon.
You control a lunar lander, a rocket landing on the moon.
You have to know something about mass and position and force and velocity and acceleration.
They could engage with these concepts but not need to know the algebra. And they loved this game. We actually had students building versions of this game, doing things like adding a fuel counter to the game, create more landing pads, stop the lander flying off the edge of the game. Things that are sort of reasonably sophisticated programming.
These are good ways to really get inside a process, really get inside a deep idea.